I'm doing fine.
Good. So you got stuff you can verbalize?
Yeah, I do.
Okay.
So we're working on recursively defined sequences,
Okay.
and so we have to find the first 6 terms of the sequence,
Okay.
and it's A1. I don't know how to say it.
A sub 1.
A sub 1 equals 0, and then A sub n equals A sub n minus 1 plus 2.
What is A sub n again?
A sub n is A and then 2.
What's to the right side of my A sub n?
Oh, A sub n minus 1 plus 2.
Okay. That's recursively defined. Okay. What we're talking about here are arithmetic sequences only. You also have geometric sequences. You also have all kinds of sequences. So arithmetic sequences are special in that every single term is separated by the same amounts. That is an arithmetic sequence, 1, 3, 5, 7. If I were to have written 1, 3, 6, that's not an arithmetic sequence. For it to be arithmetic, it has to be separated by the same amount, every number in the sequence.
That's not.
Okay. Well, notice the sequence that I just drew. 1, 3, 5, 7. And notice your recursive definition. Every term in the sequence is equal to the previous term plus 2. Does that apply to that sequence?
Yes.
Yeah, it does. The only difference is they told us that the first term is 0, so the sequence must be 0, 2, 4, 6, ... Now, do they want you to define it explicitly also, or just recursively?
Just recursively.
Which they gave you, recursive. Yeah. Okay.
Yeah.
So the sequence is 0, 2, 4, ... Okay, what else?
A sub n equals 10, and then A sub n equals...
Hold it. A sub 1 equals 10?
Yeah, A sub 1 equals 10.
And the sequence is?
It changes it to plus 2 to minus 5.
Minus 5?
Uh-huh.
Or can you speak just a little clearer into your microphone?
It's minus 5.
Okay. Like that?
Yep.
What's the difference between each term? In other words, there's my first term.
Subtract 5 from each.
I'm going to subtract 5. So my next term is what?
5.
What's my next term? What's the next term after 5?
0.
Do you just have to list 3 of them?
I have to list 6.
Oh, 6. Okay. What are the next 3 terms?
Negative 5, negative 10, and then negative 15.
Correct. Okay. What else?
A sub n equals 2, and then...
You mean A sub 1? Make sure you say A sub 1, because A sub n means something all entirely different.
Yeah. And then now we're working on geometric. So A sub n equals 3a n minus 1.
Well, let's start at the beginning. What's A sub 1 equal to?
It's equal to 2.
And what's A sub n equal to?
A sub n is equal to 3a sub n minus 1.
Okay. So let's let's see, when they give you recursive, not used to going this direction, that's odd, that you would be doing something that I hadn't encountered before.
No, it's a sub n minus 1, like that.
Ah, okay. That was what was giving me problems. The 1 is part of the subscript.
Yeah.
Okay. With geometric sequences, every number is separated by the same multiplier.
Mm-hmm.
In other words, 2, 4, 8, 16 is a geometric sequence. Every term is 2 times the previous term.
Mm-hmm.
Well, what does this tell you? They're saying any term is 3 times the previous term.
Mm-hmm.
So if we start with 2 as our first term, what are the next 5?
It would go 2, 6, 18, 54, 162.
Now what's 3 times that? 486?
Yeah, 486.
Okay. Yeah, it was going to be real confusing for me to have that out there like that because I'm not sure how to translate that back to...
Yeah.
So terminology is key here. Okay, what else?
A sub 1 equals 8. And then A sub n equals 1.5. A sub n minus 1.
What's the coefficient in front of it? What's A sub n equal to?
1.5 A sub n minus 1.
Okay. It's the first term of the sequence.
8.
Every term after that is what?
12.
Well, no. In other words, conceptually understand what that means. That means any term in the sequence, the 117th term in the sequence is equal to 1.5 times the 116th term in the sequence. So the multiplier is always that between each term. If that was negative, then it would multiply by a negative. But in this case, it's positive. So what's the next term? You got a calculator in front of you?
Yeah.
Might need it for this one.
28, 12, 18, 27, 40.5, 60.75.
That would have been difficult without a calculator.
Yeah.
Okay. What else?
Now I have to write the recursive rule for each sequence. So it's like reverse engineering that.
Okay. Give me the sequence.
243, 81, 27, 9, and then 3.
What am I doing to get to the next term of every, in other words, from one term to the next term, what do I have to do?
Oh, well, this is going to be multiplying by a fraction.
Okay.
Like 1/. So what we have to do is like divide 243 by 81.
Yeah, or you could do the easy one, just divide 9 by 3.
Okay.
You see why that has to be the same? In other words, 9 by 3, or 3 by 9, I should say.
And so then it equals to 1/3.
To 1/3, exactly. So
A sub 1 equals 2.
It's going to equal 1/3 of A sub n minus 1.
But first we have to do the A sub 1 equals 243. Because otherwise there's no start to it.
Right. Okay. So they want what A sub 1 is, and they want what the recursive definition of it is. I'm surprised they haven't focused more on this one. A sub n equals a sub 1 plus n minus 1 times d, the common difference.
Oh, we did that last week for basically.
Okay, so you have covered the explicits. Okay. It seems strange to me that they were starting off with the recursive, which a lot of my students don't even get to the recursive. They deal explicitly with the explicit a sub n formula.
Well, my teacher's more focused on like what we're going to be learning on the SATs and those types of tests. So she's focusing on stuff.
Okay.
That's a lot of it.
What else you got here?
3, 11, 19, 27, and then 35.
75?
35.
Is that arithmetic or geometric?
That is going to be arithmetic.
Okay.
Wait, not geometric.
Arithmetic because
Wait.
8 is the common difference.
Yeah.
Everything is separated by 8. So a sub 1 is 3. What's a sub n going to be?
A sub n is going to be a sub n minus 1 plus 8.
Right. Okay. What else you got?
0, negative 6, negative 9, 12. Negative 12.
Arithmetic or geometric?
This is going to be arithmetic.
I must have missed a number. There must be a minus 3 in here.
6. Oh yeah, minus 6.
In other words, right before the minus 6, there has to be a minus 3.
Yeah.
So the first term is 0, minus 3. Okay, so a sub 1 is 0. A sub n is what?
A sub n minus 1 is minus 3.
The way you said that was a little strange. A sub n equals a sub n minus 1 minus 3.
Yeah.
Okay. All right. Let me give you one.
Okay.
A sub 1?
A sub 1 equals 0.
Is this arithmetic or geometric?
This is geometric.
And what's the common multiplier?
Times negative 2.
Yeah, except not quite. Yeah. I screwed it up. In other words, notice the problem with the way I wrote this sequence. Why it is not a geometric sequence.
Oh yeah, because it goes, it's neither because it goes
0 is 0.
times 2 and then times.
So I can't have a starting term of 0. So we'll make our starting term minus 2. So a sub 1 is equal to minus 2, but what is a sub n of this geometric sequence equal to?
Negative 2.
Yeah, negative 2 times a sub n minus 1. And what happens is when you have a negative multiplier, then the sequence switches back and forth between positive and negative. Because if I multiply that by negative 2, I get positive 4, and if I multiply positive 4 by negative 2, I get negative 8, and so forth. So it goes positive, negative, positive, negative, positive, negative. And you can never have a 0 in a geometric sequence, because every number after that would have to be 0, and then it wouldn't be a geometric sequence anymore.
Yeah.
What else you got, Logan?
Another one is 5, negative 20, 80, negative 320,
5,
1,200.
go slower. 5, negative 20, 80,
80,
minus
negative
320.
1,280.
All right, this is similar to the one I just gave you. A sub 1 is what?
A sub 1 is 5.
And A sub n?
Then it's going to be negative 4. A sub n equals negative 4. A sub n minus 1.
Right. Okay.
Now I have to write the rule for, now I have to write the rule for a picture. So, do you want me to text your picture or not?
Okay. Don't text it to me. I can't use it on my phone. I can use it on my email.
It's just
send it to my email.
Oh, I mean, email.
Yeah. Now, when people send me a text photo, it doesn't show up as a photo on my phone, and when I try to download it, I can't download it. So that doesn't work on my phone. Plus, I can't bring what's on my phone up onto this screen, whereas what is sent to my email, I can.
Okay, let me send it to you.
Holler when it says sent.
Yeah, I know. I don't know if it sent, so can you check? Yeah, it's sent. Okay.
Yep. So what's the sequence here? Whoops, hold on.
It's geometric.
What's the first number of the sequence?
1.
The next number?
2.
What's the next number?
4.
Next number?
8.
That's all we needed. I didn't really need to see a picture of it. Write a recursive rule for the number of cells over time. So what's A sub n going to be?
A sub n is equal to 2 A sub n minus 1.
Right. And that's all I needed on that. Oh, I just closed out. I closed out my email. No, still got it there. Okay, what else you got?
So it's 4.5, 4 3/4, 5, and 5 1/4.
Yeah, you usually only need 3 terms. 3 terms will define it almost always as either arithmetic or geometric. And once you know which one it is, then you can figure out the rest of the terms yourself. Is this arithmetic or geometric?
This is no, it's arithmetic. Right?
It's arithmetic. A sub 1 is 4.5. What's the recursive formula?
It's going to be 0.25.
What is it? It's the previous number
or 1/4
plus 1.
Oh, A sub.
Right? In other words, if we look at this sequence, no matter where I start, if I want to know what that is, is all I need to know is the previous number and add a fourth to it. So what a sub n minus 1 is the previous term in the sequence. So if you told me a sub n minus 1 is 176, then I know a sub n is 176 and a quarter. That's what recursive means, is you are defining a sub n as a function of its previous term. Now notice that wouldn't help if I said, what is a sub 117? The recursive formula doesn't help much, because I don't know what a sub 116 is. Right?
Yeah.
That's why the explicit formulas are a little more valuable, because you can figure out any term in the sequence without knowing anything but the starting term and the common difference. In other words, I would have, if I were to, instead of giving you the explicit, the recursive, I'm going to give you the explicit, and what that says is a sub n equals the first term plus n minus 1 times the common difference, which is 1/4. Now, if this is what I know, now I can tell you what a sub 117 is. Pretty easy. A sub 117 is 4.5 plus n minus 1 is 116 times 1/4. Whatever that number is going to be the 117th term of this sequence. So you can kind of see where the explicit formula is quite a bit more valuable than the recursive. The recursive only works if you know what the previous term is. And when I ask a hard question like, what's the 117th term? Well, I don't know what the 116th term is. So the recursive doesn't help that much. It is a way of expressing the sequence, though, and sometimes it helps. I'm not sure when, but I'm not sure when the recursive is better than the explicit. That's why 95% of my work with students on arithmetic and geometric sequences is always in the explicit form, not the recursive.
Yeah.
The recursive doesn't really let you solve very many problems. All right, what else you got?
That's it.
Okay. Have they gotten to sums yet?
Sums? No.
The sum of a sequence?
No.
Okay. They probably will. I don't know if they will or not. You're in 9th grade algebra. They're going to touch on sequences, but they're not going to get real deep into it. Once you get into Algebra 2, then when you study sequences, you'll get a lot tougher questions. But sequences is a little bit like trig. They give you a little bit in Algebra 1, a little bit more in geometry, a little bit more in Algebra 2, and then finally you take a trig course and you learn a lot more. And sequences is similar. They're giving you a little bit of sequences. Like you said, probably for the purpose so that you can actually take the ACT or the SAT. Although by the time you are seriously going to take that, you will have had Algebra 2 also. Right? In other words, you don't really need to take those tests until you get to be a junior. And junior year, you should be taking Algebra 2. So by then, you will have learned everything you need to know that's included on the SAT test. All right, Logan, I will let you go, and I will talk to you next week. Now, you sent me a message saying Bolton couldn't make this Tuesday session. Was it just this Tuesday?
I don't know. He just told me to text you. the selection. I'll ask him.
So should I? Is he there right now? Is he planning on doing next Tuesday at 4?
Let me go ask him. He's gonna do it next Tuesday.
Okay, so I'll leave him on the schedule. So I'll leave you guys from 4 to 5:30 on Tuesday. Until I hear otherwise. And thank you for the advance notice that you gave me. That's very helpful. I was actually able to reschedule that time slot today. So, yeah, the more advance notice you give me on cancellations, the better it is.
Okay.
Okay? All right, Logan, have a good one. I'll talk to you next week.